Welcome everyone to the first of our Getting Practical with MBSE presentations in June, From Concept to Design, Making MBSE Real-Time, presented by Ron Kratzky. My name is Donna Long and I will be your host during today's webinar. Our lead presenter today is Ron Kratzky, Principal Systems Engineer at Vitek. He is a retired United States Navy officer with over 20 years of engineering experience managing nuclear engineering and combat systems on surface ships. Ron was introduced to the systems engineering practice near the end of his naval career while conducting mission and capability analysis for the Navy staff. For the last 15 years, he has worked as a systems engineer supporting advanced systems development for a number of federal government agencies. He was introduced to CORE in 2007 and utilized CORE to manage system development tasks on 3 different projects in the 5 years before he joined Vitek. He is now a provider of professional services in GENESYS and CORE, as well as a central part of the Vitek training team. Before Ron gets started, I have a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Ron will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be available within 1 business day. The recording will be published to Vitek's webinar archive located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Now I'm going to turn the presentation over to Ron. Welcome and thank you for joining us.
Thank you, Donna, and good morning to everyone out there listening to this webinar. Today, this is the first in our series, as Donna has mentioned. Today, I'm going to talk about starting a project, a system design project. So when we think of systems engineering and we start into a project, many times we get overwhelmed by the amount of information I have to provide. Stakeholders demand a certain level of understanding in order to approve the design that we're going to put together. And at the beginning of a project, you immediately start thinking about, you have visions of all the documentation I have to provide and how is that going to work. The path through approval with the stakeholders is often arduous and requires just an enormous number of views and presentations and things that you have to do. Looking at all this, particularly the start of the project, people get easily overwhelmed. And on top of that, we think of all that information and we think of how am I going to get all that information? How am I going to manage it all? We look through the artifacts and we realize that there's just an inordinate number of elements that we have to produce to create all the different views and documents that we have. Some of the elements go beyond just the basic specification of the system. Stakeholders want to understand risks and concerns and rationale for how are we doing this? Why did you do that? And their amount of scope, the things they want to know, is ever increasing. The mere fact that stakeholders require so many views with so many perspectives with varied information means that we're obligated to build and contain all that information. And we have to have a certain number and kinds of data. The extent of this information demanded leads us to needing a way to handle more than just the system spec. We have to handle all those views. So model-based systems engineering, it was developed and it's meant to help us handle all that. But how do we begin? We have these huge number of views and this mountain of data that we have to look at. So what I want to focus on today is taking a step back. I want us to think about not the amount and the burden of all that information, but just take a rational look at some systems engineering basics and figure out how we can start a project. We want to let the model-based systems engineering environment handle many of the details. We want the model-based systems engineering environment to look at the complexity, and that's brought out by the prior slides that I talked about, or that I just showed. So what I'm going to show you over the next series of slides is how to look at some of the basic things in systems engineering and to put those basic elements into the design model in a very simple, straightforward, graphical way to do that. And let the model handle all the data structure issues. So we want to be able to do a design and free ourselves to do the design and the thinking and let the model take care of all of the bookkeeping, all the relationships, all those things behind the scene. So again, our focus here is let the model do the work and let us do the thinking. So taking a step back, if we think about the very fundamental things in systems engineering, we think about requirements, functions, and components, right? We know we have a set of requirements. That's generally how a customer communicates to us. There are probably needs at the very beginning, but eventually those needs become the basic requirements for the system. Within those requirements, then, we have to figure out what functions, what do we want the system to do? And then we have to figure out, if I have to do all these things, then how am I going to allocate those to some component or physical architecture? So let's just think about these things at the beginning of the project, not all of those other things that occur. All those other data elements, the verification requirements, the risks, those things will come out of the analysis of these three basic fundamental things. And if you think about it, there's naturally some sort of relationship between them. Requirements give us some definition. Some of those requirements are going to define for us a series of functions that we have to perform. And as I said, those functions end up having to be related or assigned to, what we call allocated to, components in our architecture. A component in the architecture exists there because it does something for us, and those functions have to be allocated to a component. So there's this natural relationship going on here. We intuitively understand all these things. Again, what I want to focus on is not the relations, but let the model do those relations for us. Let's think about the requirements we have, the functions we have, and then look at how those functions would be allocated to some components. So in order to do this, we're going to start with a very basic model. So let's start with a basic understanding of something that a customer might need, and let's work from that point out into doing the actual design. So we're going to assume now, for the first part of this seminar, that we have a very basic project. We talk to a customer. The customer wants us, or wants to be able to, request images from some central library. They want to receive the images, want to get some images back, which they make the request, and they want to basically task the library to say, if you don't have the image, go find it and go get me one that'll meet my needs. And so the customer has given us these basic couple of requirements here, and they've given us this little diagram that you see on the right-hand side of the slide. So it's basically and what I'm going to call a geospatial library. So I'm going to do a beginning model for the geospatial library. So in order to do this, I'm going to make a transition over into CORE, where we can actually start doing some model development. So let me escape out of this presentation mode here. And now you'll see that I have a very basic, I've opened a blank project actually in the geospatial, in CORE, and it's a geospatial library module. What I'm calling, way up here, what I'm calling the geospatial library, the GL concept model. Now in CORE, the very first thing you notice in CORE is, and many of the things I'm going to show you in CORE are very similar in Genesis. We have on the left-hand side, we have a project pane. This project pane allows us to navigate into the model. So over on this far left-hand side here, you'll see things that allow us to get into the model. And now I'm in this facility here called Essentials. So Essentials here is giving me a basic set of things I would want to look at the very start of a project, the essential elements of any engineering project. There's different facilities here. Those facilities expand upon this essentials list based upon the role that we might be playing in a project. So if I was a systems engineer, I might also look at the systems engineering thing, the systems engineering facility, which will also cover all of these classes here, but it will include a series more. But I'm going to stick right here in the essentials class, and we can do most all of the work we're going to do today. We're going to be able to do right out of this essentials area. The next thing you'll notice in the center here, or one over from the left, is an element pane. The element pane allows us to see all of the particular elements or items of whatever class we've picked over here in the project pane. And then when I select a class, that class provides that, then once I select it, I get a whole bunch of details over here. So now I have more information on this. These panes are movable, so I'll slide this over to give us some more room. So here we have system context, and when we start in the model, we generally start with a system context to say this is the environment or the context in which our system will be operating, okay? So if you remember here, we had some requirements on that slide. Let me see if I can bring that slide back up momentarily here, just so we can all refresh our memory here with what's on that slide. So this is the slide, right? We have some request images, receive images, get an image in the data bank. So here's some basic requirements, and what we want to do is try to capture those requirements in our model. And then we'll look at this graphic and see if we can capture the intent of this graphic. Okay, so in requirements here, I'm going to start and create a new requirement. And if I just right click on requirements here, I can get a new element in the requirements folder. The first thing I want to do is I'm just going to create something called overall system requirements. So we'll use that as a placeholder, if you will, for the 3 requirements we need to make. So here I have overall systems requirements. I can look at these requirements very graphically. Up here we have a series of buttons that allow us to look at things in a graphical format instead of this very textual format. So I'm going to go to this graphical format, and I'm going to open up, let this hover here, a requirements diagram in the systems modeling language. So here's the very basics of that diagram, okay? And what happened here is I opened up the overall systems requirements, and now I have some requirements I want to make. So I have a new requirement in my model. The first requirement to handle the accepts request, so I'm going to call this requirement accept request. And you'll see that as soon as I did that, when I brought that, drag and drop that over, I can make that requirement accepts request. Now the symbology here basically means that this requirement accept request is a decomposition of the overall system, the upper level element, which is the overall systems requirements. Well, I have 2 more requirements that I need to add here. And one of these is to provide products. And the next one is, again, dragging and dropping these new requirements. I have one more, which I'm going to say get product from inventory. All right. So very simply there, we've created a basic understanding of all of these requirements just by doing this graphically, okay? Now there is another diagram that is used in requirements management. I'm just going to shrink this down a little bit. And that diagram is a hierarchy diagram. Well, I can navigate to that hierarchy diagram by clicking up here. You'll see the button that's on the upper right-hand side over here. So I'm going to take that, I'm going to open this, and you'll see here that I could open up a requirement diagram or a hierarchy diagram called requirements. If I click OK, I'll see a very similar diagram. Okay, so one of the things the model does for us is it allows us to keep track of these diagrams. If I'm diagramming in one model, the other model automatically will be, the other views will automatically be generated in the background, ready for me to look at whenever I want. So all I have to do is click on them and open them. And when I make a change to any of the diagrams, that change will be reflected throughout the other diagrams. So if I was to just I'll just add a new requirement here on overall systems, and I'll call it requirement 1. And as soon as I add that requirement 1 here on this particular model, on this particular view, this is the systems modeling language view, that requirement also shows up here, okay? And just so you can see this, textually in the database, that requirement is also there too, okay? Now, interesting thing is if I was to take and number these requirements, I can number them from here, or I can number them from the diagram. So I'm going to go back to my diagram here. I'm going to go back to the systems modeling language diagram. And now that I'm on this diagram, you'll see that there is no numbering on this diagram because of the way those views are shown. But over here, I can use the numbers. So I'm going to take overall systems requirements. I'm going to select that. And then in the diagram mode, I can just right click, renumber the element, and let me give it the number. I'm just going to say R for requirements. And when I do that, you'll see that all these things are numbered down here. Now, this particular view shows numbers. This particular view doesn't. And that's because of the rules for the different views. This particular view here is written to the systems modeling language standard. So in the systems modeling language standard, we don't put any unique numbering into those blocks. We just keep the requirements there. Over here in the hierarchy diagram, we do have the numbering part. And then if you look here in the model, these are all numbered here in the model for us to see. So what I'm going to do here is, this was just an added requirement. I don't really know that I want to keep it. So I'm just going to right click on this and delete the element to get it out of my database. So I'm going to take it out of the database, and then I'm going to go back to my two diagrams. So I'm back here on this overall systems requirement diagram. Okay, so if I look at these, accepts requests, get product from inventory, provide products, these are all functional requirements. So these are all going to have some sort of function associated with them. So again, from here, I can start looking at this, and I can just look at what are the functions. So I'm going to take a new thing. The accepts request is going to have some function associated with it. I'm sorry, I picked the wrong one. I want to go to accepts request has a function associated with it. I'm going to call the function accept requests. Okay, so this requirement accepts request is going to be satisfied by this function called accepts requests. And I'm going to do that again for get product from inventory and provide product. So again, I'm going to have a function here that's called get product from inventory. Okay. And then I'm going to have some function in my system that says provide the product. Okay. So now I have a series of functions down here. So down here is where I have my functions, which I just highlighted. And these are the requirements that are providing the need to give those functions. So going back to my model here, going back to what I had here, I've got these requirements and these functions in my model. I want to look at this. They have this diagram here. The customer has this diagram, and this is indicating that the thing I'm trying to design, the geospatial library, is going to have some interfaces here to customers and collectors. So, well, how would I do that? This is a requirements diagram. Let's just leave this a moment. And I'm going to close the other requirements diagram. But by the way, before I leave here, notice that I changed the first diagram to put the requirements in here, and now I have these requirements on here. So this requirement is the basis of this function. And here we're showing the actual relationship, whereas in the systems modeling language diagram, we had the dotted line with the satisfy label on it. So two different ways of seeing the same information. The advantage to that is on your team, you might have some people that are well versed in the systems modeling language, other people that are not so steeped in that, in understanding that standard, so that you can design in either one of these diagrams, you're all going to have the same information available to you. So again, this picture that we have has customers and collectors and the geospatial library on it, and we understand those to be components in our architecture. So let's switch to the component class, which is up here. We have this thing called system context. All right, that's there, that's fine, but I really need a customer, collector, and geospatial library in order to show what my system, or the things my system has to interact with. So let's make some elements here. We can start by right-clicking and saying a new element, and we could say customers, for example. Or we could go into grab system context, and we could look at the structure block definition diagram for system context, and we have this. Now, so I have this big model here. Let's go to, I'm going to create a node. I'm going to drag and drop. I want the system context to be built from this customer. So I'm going to add the customer there. So I have system context and it's being built from the customer, but I also need a geospatial library and a collector because that's what the diagram showed me. So I'm going to go over here. I'm going to drag and drop another node on here that I'm going to call the collectors. And I'm going to drag and drop one more node on there for the geospatial library. All right, so I have my system context being built from these three elements. That's what this little diamond, this little notation on the systems modeling language diagrams indicates. So let's just we can clean up the model just a little bit. I just wanted to show you a little feature here. So if I wanted all these to be this size, once I size this one, I can hold the shift key down, select the other one, the other elements, and then I can go to make them set equal height. So now I have a much cleaner looking diagram. And this particular one is my system of interest, right? So this gives me the basic contextual diagram of this is how my system is broken down, a physical hierarchy. Well, there's probably a hierarchy diagram that goes along with this. So if I go over here to the corner here again, and I click here and I see this, I can look at this time, instead of a requirement hierarchy, I want to look at a physical hierarchy because these are components, right? And I'll get this view. Now remember what we did before? I want to organize this data so I can understand it a little more. Right from here, I can say renumber the element, and I'm going to put the number C in there. Capital C. I like to use capital C's for numbers, capital letters for numbers. And I get this. Now, so I have this as an external component, and this is an external component. Well, I want my system of interest, my geospatial library, to be special here. This is where I'm going to design. This is what I'm designing in the context of these two externals. So I'm going to select this. I'm going to renumber this. I'm going to give this the number SYS. Now, the reason I like to do it this way is because this indicates my system of interest, and as I start building the system, I go deeper and deeper into levels. The SYS.X numbers would be subsystems, and as we go down further, it'll make a nice little hierarchy of elements within the system. So I have a system context diagram. I figured out how to get all these to be organized. And when I go back here, you're going to see that these are nice and ordered here. But I have the context diagram. This is the structure block definition diagram again, just to show you this is where that diagram resides, where that button resides. Now, the next thing I want to do is I'd like to show the interfaces. So because my diagram showed that I had interfaces between customers and collectors. So what I'm going to do here is I'm going to switch to an interface diagram. And now I have an interface diagram here, or the beginnings of an interface diagram. And I have collectors and customers and geospatial library. So let's organize these things a little bit. And let's think about how I want to connect these. Just like I did before, there was a sizing button, but I can also take and select, do this, shift, do this, select the other second one, and then I can align the, the nodes with this button. So what do I want to align? I want to align the top, bottom, middle of these, so they're perfectly aligned there. Okay. So I know that I need an interface between the customers and the geospatial library. I don't know exactly how that interface is going to work, but I know I need an interface because somehow the customers have to give me some information and somehow I have to be able to communicate with the collectors. So there's a couple of different ways to do this. I can start here by saying, oh, I need an interface with the customers. So I'm going to take this, I'm going to say new connection, I'm going to drag and drop it on here because I know I need an interface with the customers. So I'm just going to call this the customer interface. And I like to put the I/F there so that I know it's an interface. So this is a customer. I'm going to call this the customer interface. Okay. Well, what I've done here is I've connected the customer interface to the customers, but now I need to collect it to the geospatial library. And I have this interface already in my architecture. So what I'm going to do is I want to choose that connection and connect it to the geospatial library. So now I just do this. When I do this, I want to add this to my geospatial library element. And when I do that, it makes that connection for me. Now, I want to move this connection around the block. There we go. So I'm going to do the same thing here with collectors. I need a new interface for collectors. So I'm going to go new connection, and I'm just going to call this collector interface. Now I have a collector interface. Now I want to connect that connector interface, this collector interface with the geospatial library. So what I want to do is make that connection on the geospatial library. This is the collector interface. Well, say I can add it over here and say okay. So here's the collector interface. All right. So now I have this diagram, and this diagram here looks remarkably like the diagram that I have here. I have customers, geospatial library, and collectors. So I have these guys in this diagram, and I've represented that in my model here. And again, I did this graphically, pretty simple, pretty easy for me to understand. And you can see here that I have the interfaces in the model, and these interfaces are connecting the appropriate components. Okay. So I've got the interface diagram, I've got some of these requirements, but I want to understand the functionality. I'm going to switch to the function class for a moment, and I have these three functions: accept requests, get product from inventory, provide products. Okay. So these are all part of the system, right? So I'm going to start by, I'm going to create something called, I'm looking at system performance. So I'm going to start here by making a new element, and I'm going to call it system performance or system function diagram, whatever you want to call it. Okay. So I want to open this diagram, and I'm going to use something called the EFFBD, Enhanced Functional Flow Block Definition Diagram. Okay. So I have these three functions. So let's just take those functions. And if I grab nodes here and I drag and drop on here, I want to put those three functions that I have into my diagram. So let's put accepts requests, get product from inventory, and provide product. You'll notice that those go in there exactly the way that I selected them. Well, in order to accept requests, we have to have something that's going to give us the request. And in order to provide a product, I got to give it to somebody on the other side. So here's where now I need to start thinking about this a little more. So if I'm going to do this, to begin with, somebody has to make a request. I'm just going to call this make request. All right. And if I'm going to provide the product, I have to give it to somebody. So someone's going to, at the end of this thing, receive the product. Okay. Now, if I think about this, The three things I have in the middle here are what my system needs to do. Somebody outside the system, the customer, is going to have to make a request. And once I get all done, I have to give him this thing back or receive whatever this product is back. So how am I going to do that? Well, what I want to do is these two things are going to occur, if you will. There's things the customer does and things that I do. I react to the customer and I give something back to the customer. So what I'm going to do here is I'm going to drag and drop a parallel branch on here. Okay, so that's right there. What I'm going to do here is I'm going to grab the make request. I'm going to hold the shift key down and grab the receive the product. And I'm going to cut them. I'm going to put them on my clipboard through the cut function. And I'm just going to paste them at the top branch. And then I'm going to take the three down here and I'm going to cut them. I'm going to put them on the bottom branch. Okay, so now I'm starting to understand the customer's going to do something, I'm going to receive, and then I'm going to do something, gives him something back. I want to make a little more spacing in here so I can have more room to do some design, some more thinking. Okay, so I'm going to take expanded placement here. That gives me some more room in my diagram. So if I think about this, I just want to sequence these a little bit. I got to do something here, and then I want to come down here and do something. Well, the way that works is, and you see the ease with which I'm moving things around to help graphically organize stuff. So if I think about this, make request has to send me, they have to send me a message to say, hey, somehow they got to communicate with me, say, go get me an image. So I'm just going to, so what I'm going to do is I'm going to select make request. I'm going to hold the shift key down and do accept request. I'm going to do it a different way here. I'll do it a very simple way. I know that I have to, that make request has to give me, they have to make some sort of message. So I'm going to say that they have make request as a new output. And that output is, I'm going to call it information request. So I have this thing called information request. I did this the wrong way. This is an output. I drug an input in here, but that's okay. So let's look at how easy it is to correct things here graphically also. So when I made a mistake here, and rather than making this coming out of here, I actually made it into an input. So what I'm going to do here is I'm just going to cut this off of here. So now it's no longer there, but I want to make it an output from the make request. So I've got it in my model. I can just go like this, and I can switch it around just that easy. So now I have an information request here that's coming out, and I want this to come into accepts request. But what I really want to do is it to be able to control or trigger accepts request. So I'm gonna look at accepts request, and I want to select this information request. I'm only going to do this processing when make request sends me a message. So that's going to be a trigger. So I'm going to go to accept requests, and I'm going to grab this, add it, and say okay. So now you see when the customer decides to make a request, it'll trigger us or tell us to go do something. And in the end here, I'm going to do a provide product back to this side, to the customer side. So I'm going to take this. This time I'll do it a little bit of a shortcut. I can grab this, and I can hold the shift key down and select receive product. Then there's a little button up here that says connect the nodes with an output from one and a trigger to the other. So I can do it this way, and I can make a new one, which I'm going to call the product, and say okay. So now I have the product here, okay? And now just to make things a little clearer, I'm going to grab this, I'm going to right click, and I'm going to say edit annotation, and I'm going to make this the customer side. And I'm going to make this one here I'm going to make it the geospatial library. Okay. Well, that handles the things that that are interfacing with the customer, right? So these are the things we have to do to work with the customer. What about the collector? So what this thing, as I'm thinking here, this is great if the product is in inventory, but if it's not in inventory, then I've got a few more things I have to consider. I have to figure out what else do I need to provide, or how do I interface with the collector? So I guess that's going to require another branch. Well, I know it's going to require another branch, I don't guess. And we're going to have to do something here with the collector, so I could easily just take this and say, okay, this is my collector branch. Okay, but somehow in here, if what's missing here is, as I'm thinking about it, if it's not in my library, it's not in my inventory, I have to go task the collector to do something and put it in the inventory. So I got to add, I need something in here that says check in the library. So let's make a new node right here. So I'm going to put a new node in there, and I'm going to call this node, let's say, check database inventory. Okay. So I'm going to check the inventory, but when I check the inventory, it's either going to be in inventory or not in inventory. So that means I'm going to have two ways to exit this function. So I'm going to make a new one called in inventory. And then I'll make another one that says not in inventory. So if it's not in inventory, I'm going to have to task the collector and get something back from the collector, right? So I'm just going to make a couple more things here. So if it's not in inventory, I'm going to task the collector. Or and then when I task the collector, he's going to go do something for me. Well, let's think about this a little more. Task the collector. So when I task the collector, I want the collector to receive the tasking. And then I just move this over a little bit. Once he receives the tasking, he's gonna go do something. What he does, how he gets that, is not really my main concern, because I'm engineering the geospatial library line. But eventually, the collector will send me back, will provide me some new data. And once I get that data, then I'm going to I'm going to provide the new data. I'm going to put that data in inventory up here. So let's just clean this up a little bit. It's very easy to do this graphically, just move things around. So tasking collector, they're going to have to send a message to say, tell the collector to do something, right? So when I task the collector, if I look at this, I'm going to send out a new message. Now, I can do the drag and drop thing again. I'm going to take an output out of the collector, or out of the from the system, and I'm going to send a message that I'm going to call collector tasking, and that's going to go into the collector. So the collector is going to receive the collector tasking, and then I'm going to, when I get the new image, I'm going to take this and send this. I'm going to use the two-node method again this time, and it's going to be new image data. And resize that a little bit so we see it all. So if I think about this, the collector is going to make a request. We're going to accept the request. We're going to check the inventory. If it's in inventory, I just need to go get the product and put it in the in the and give it to him. If I check the inventory and it's not an inventory, then I'll task the collector, and then I'll place the product in inventory. So that seems to make a lot of sense to me. We do have a feature in CORE, which we're going to talk in some detail about in later lessons, or in later webinars. But if I open the simulator here, you'll see that I can do an actual simulation. Okay. In this case, the provide product tasking, the bottom line didn't work because it took the inventory pass, so these two never responded. And there's ways to fix that in the simulator. There's a couple of different things you need to do this diagram, but at least I have a diagram here that I can talk to the customer about and see if this is what he wants me to do. So between this is the functionality he's asked me to provide. Between this and the component diagrams that I showed you, here's my interface diagram. And then here is my requirements diagram. I have a way to start talking to the customer. So I can look at this, I can go back to the customer, the stakeholder, and say, let's look at this. We look at that. We look at this diagram. We look at this diagram. Are these the things you wanted me to do? Are these the things you've tasked me to do? And so we have a great way to do this. And we did all this by doing a graphical model, and we allowed the model to handle all of those information things behind the scenes, all this functionality here. If you look at this here, if I was to put this, if I gave this a number, if I just said function, and then if I just renumbered this, you'll see all these things become numbered. So I have all this functionality here that's shown by this diagram, and I also have the physical architecture, the physical hierarchy here in this, and also the interface diagram. So just with this basic bit of information, allowing to do the drawing in drag and drop fashion, we ended up providing a lot of information and did some design work, and we let the model handle all of the particulars. We just did the drag and drop and made the drawings the way we would like to see them. So what I'm going to do next is, just to bring this point home a little further, I just want to show you briefly a model that's built out. And when you get, when you look at our solution set in Genesis, you'll see the geospatial library sample model, and this is that model extended a little bit to do some additional things. But this is the model, and you'll see here you have a bunch of requirements here. Here's requirements. The models, this model just has more information in it than the other model. And so what we now see here is a whole series of requirements that have been built out. Excuse me. And we'll also see a whole series of components. Here's the physical context, and here we have the geospatial library, the customer, the collectors, the certification authority. And when we go through the class, we talk about how that certification authority comes about. But let me look at that model in a physical hierarchy format. And so as you start building this, you can get more replete and models with more detail. So now we understand this to be our system of interest, and we understand these to be the external systems we have to interface with. And I can look at, you'll see a diagram here. Now in this particular interface diagram, you notice I have the geospatial library here, and I have the customers here, and the collectors, but through the design process, we also determine a certification authority. Then this diagram is also showing the workstation and how the workstation interfaces with these externals, and the command center and how it interfaces with these externals. And all I did here to put these graphics in here was to switch from the icon bubble to a graphical image. It's one of the things we do and a lot of diagrams to help us communicate with the stakeholders. Again, they probably resonate with the diagram, the graphics, more than they do the icons with technical detail on those icons. requirements diagram. That the requirements diagram can get really lengthy. So here is the requirements diagram in the systems modeling language. You'll see here that in the requirements diagram now I've got several more requirements, but I have the top level requirement here, system specific requirements, and then if I go back over here, you'll see the accept requests from customers, and we accept requests, we certify the customer. Here's some verification requirements in there, okay? And that's the way that particular view looks. If I switch to the hierarchy view, you'll see the requirement hierarchy. So this view is a little bit different in the way that I have it constructed, because now I have an organizational drop down here. So rather than having the continuous tree, I do this vertical part of the tree. So you can see, so this requirement accepts requests from customers is refined by this one requirement here called accepts requests, and then another one for certified customers, and here's the verification requirement for it. Okay, here's the functions for some of these: maximum staff, control multiple collectors, control multiple collector types, some refinement of those requirements. And then finally, in the big model, the more detailed model, I'm going to switch to functions here. And if you look at thread 2, for a moment, I'm going to open the EFFBD at thread 2. That looks remarkably like the model that we had just done. So we have an information request coming in. We look, if it's not an inventory, we determine all the things we have to do, and then we send it back to the customer. We task the collectors down here, and then send it back. So you can see that just by doing the few things that we did, we got a jump start on the model and how to create various things in the model. Not worrying about the diagrams, not worrying about how to get all this textual information in. We merely focused on taking some simple things, the requirements that we were given, the components that we were given, the drawings we were given, and just by drag and dropping and doing things graphically, we're able to put some elements together. Now, one interesting thing about this big model is, now that I have some more data in here, I want to start looking at, how do I control this? Does the model help me? So the first thing I want to do is I want to look at some diagnostic checks. So I'm going to go to and run a couple of reports here for you. So again, for this model, right, we have the ability to look at things and see what's happening. In any particular property page, we have a tab here, diagnostics. What I'm going to do is run a script here to look through a series of elements. So I'm going to do this on requirements. I'm going to select requirements here. I'm going to run this diagnostic report on requirements. It wants to know if I want to open it up. And so here I have a report. And this report is highlighting 2 requirements that are not complete. So the report here tells me that these 2 requirements don't have an origin set. They don't have a type set. The element is a leaf level but doesn't have a verified by relationship. The element is a leaf level but isn't related to the architecture, is basically what this is saying. There's no specified by or basis of relationship. And some other things with this one. So this is a diagnostic report in a textual form. If I go back up here, you can also see the same report in a table form. I'll do the same thing on requirements here. So this is giving me a table. Sometimes the table is easier to understand. So I see that these are the types of things I have to fill in. I don't have any other errors in there besides these that are listed here. And so you can do this report on more parts of the model or different things, but if I just was trying to get my requirements straightened out, that's what I could do. The other thing is, because I have all this information in the model, I can also write some other textual reports. So if I go back up here to all reports and I want to run a report on the whole system, so I can go to system description document, primary component. Yeah, I want to run it on my system of interest, right? And these are all the sections I want to add all all the sections of the report. So there's various sections in this report that get populated. And I can choose which diagrams I want. So I'm just going to leave these diagrams here as the diagrams of choice. And when I open it, it's going to say you want to save it someplace. So you have to mark someplace to put it. I have a demo folder here. So I look at this document here, excuse me, not diagram, document. You'll notice that it comes out as an RTF document. So what I can do here is, if I go to select all and then select F9, this will build the table of contents for me and the list of figures and things, because it's an RTF tag document. And you go in here, we have all the information for the design is now in a very much textual form here. It gives you that document that you can deliver to the stakeholders so they can really look at and examine all the work that you have put into it. Okay. And this document ends up being so complete that we actually look at terms and different things, but you can see here different parts of it. Here's this function, this item called collection products. It goes between two components. It goes between components as shown here, output and transferred by what actual interface link it uses to do that. And this is all extracts of information from the model, from all the data that we've put in. I want to go all the way to the bottom here and show you that we also pick up acronyms and definitions that are used in the model. And I think I got time. I'm going to run one more, and then I'll conclude the presentation here. Okay, so I ran the SDD, and now many times people just want the spec. Give me the spec. So there's a thing called the system segment specification right here. I'm going to run that on a geospatial library model. Again, add all. And it's going to say, where do you want to save it? I'm going to save it there. So it's running that spec for me. I'm going to select all, F9. And again, all that's doing is just building the table of contents and things. And table of contents and the list of figures and all that, because everything as we pull things out, we give them RTF tags. So a lot of the same information is in here. We start looking at requirements and diagrams and pictures and stuff like that, systems capabilities. Here's the different requirements that are listed here in the interfaces and links and things like that. But the unique thing about this is at the very back here, because I have verifications, every spec has to have verification. So here are some of the verification requirements that I have. And so this is a particular verification requirement, excuse me. This is the description of the requirement from the verification class. And these are the exact requirements in this document that this test is going to verify. So whenever you write a verification requirement, you have this verification cross-reference matrix. And you'll see here that there's a couple. You know, many times I run these products, and I'll see things that I miss. So here you can say that you missed completing. How am I going to verify these two functions? And you also have this here, and I wanted to show you one other thing here. And then we have requirements traceability. So these are the requirements that I have in my document. Here is their project unique identifier and where they trace to. These particular requirements are coming from this particular document that was given to us. So we have a requirements traceability as part of this document also. But I'm not building that from hand. I'm letting the model keep track of all that, and then we just run the script to allow the script to handle putting all those things in. Don't save. Okay. So let me go back to my presentation here for a moment. So to kind of bring this all back together here, what we did is we took a step back. We know we need all these things. We know we have to provide things to all the different stakeholders. Rather than trying to construct an individual tailored view for each of these each of the needs for all the stakeholders in something like Visio or PowerPoint or whatever, we allowed the model to draw the views for us. We looked at the information we were given, we started to think about it, we put it together the way we wanted to do, the way we wanted our design to occur, and then we're able to communicate with the customers. By doing our work in the model-based environment, we allowed the model to do some of that bookkeeping for us. The model helped us to keep the design integrity. The diagnostics told us where we had errors. The model helps us see the design in many ways. I showed you 2 different views for requirements diagrams. I showed you 2 different views for the physical architecture, the physical hierarchy and the interface diagram. So just by creating those, we added elements to the model, and the model kept track of those. The models helped keep the model working in the background, kept the views consistent. So when I changed one, I changed the other. They kept everything consistent. I didn't have to open 2 different files and change it in 2 different places. I changed it once and saw it in several places. And I showed you in the new the more replete model, we changed the way some of these diagrams looked by putting some graphics in there. So we tailored the view to meet the needs of a particular audience. The model also allows us to present things in a textual way, provides us tables and written documents. The artifacts are a representation of the data, again, in the model, and it's not really, it's not an interpretation of a Visio diagram. It's actually bringing the information out that's part of the elements that are of that diagram. So in essence, what we're doing is we're designing in a very easy and efficient way and allowing the model to handle a lot of that the background work for us, of keeping the views complete and showing us where we have to continue to do work to finish out parts of the model. So with that, Donna, I'll turn it over to you and see if you have any questions.
Thank you, Ron. We do have a few questions, thanks to all our participants. I encourage you to join the discussion now and submit your questions using the webinar control panel. If you do need to leave the webinar, please take a moment before you go to respond to the quick survey that will pop up on your screen. Our first question comes from Amy. How do I find requirements that do not have verifications written for them?
Well, that's a good question, Amy. I showed you some verification requirements. So this particular class here is verification requirements. So we have a number of verification requirements written. But what we want to make sure is, and if you look at some of these, so we have a verification requirement and it verifies a particular requirement, right? So what I like to do is I'll go back up to requirements, and we have a thing here called filters. So right now this is an unfiltered view. It has all elements in there. So I can select this filter. I can select various different filters, and these are the ones that are provided in the model by default. But I can look at unverified requirements. So I can filter for all unverified requirements. And notice that when I do this, when I apply a filter, this particular pane is changing color to green, okay? That tells me I have a filtered view. And I have a list of unverified requirements here. If I click on one of these, you'll see that there's no verified by relationship. So I really need to look at these elements and create that verified by relationship to make sure it has a verification requirement. Now, one more thing about these is I have all of these elements in here and I have those filters. I can also go to data, edit filter, and this is the way to change the filter. So let's look at that verified requirements filter for a moment. And so what the unverified requirement filter did is it looked through requirements and found all of the targets refined by is empty, meaning all of the leaf level requirements. And then I looked to make sure that all those leaf level requirements had at least one verified by verification requirement with it. So it's a pretty quick, simple way. It's a great little tool to have, and you can create your own just by looking at some of these and customizing some new ones to fit your needs. Okay.
That sounds like it answered it to me. The next question is from Doug. How does the activity diagram look, and can you show me one?
Sure. So let's look at one here. This is in the big model, so I can switch back and forth to another model, but this is the one that, well, let's look at this one here, different one. Very simple way to show this. So this is a product and inventory. So here they're going to make the information request, accept and format the request, get the product, provide the product to customer, and accept the products, right? This is an EFFBD diagram. If you look over here, I have activity diagrams and some other diagrams, which most people will generally work in an EFFBD or an activity diagram. Well, this is now I'm going to switch this view to show the activity diagram, and this is the activity diagram of that same information. So a lot of the symbology, the graphics are the same. What we don't have here is the triggering items are not green, they're white, and they have a single-headed arrow, and the things that are optional, the data stores that go back and forth between a lot of functions, have this optional tag on them. So this is the way that, and the other interesting thing about the activity diagram is the symbology here for the for various constructs is different. So this big black bar here is the AND construct, and that's the same that you see here. Instead of the AND being in there, you have to know that that black bar represents, that symbology represents the AND. And if you look over here on the left-hand side, you'll see the AND or parallel construct, the select, which would be an OR. The loop would have a diamond in it. So different ways that those are represented. But they're the same diagrams. They represent essentially the same information. That's just that the language, I don't want to say syntax, but the symbology that you see there on the diagram is different in an EFFBD than it is over the activity diagram, but it's the same information, just rendered differently in the graphical view. And as I change this information, the model will keep these two views consistent. Okay. Anything else?
Thanks, Ron. That wraps up the Q&A for today's presentation. If you have any other questions or comments for Ron, don't hesitate to send him an email, or you can post your question and comment on our LinkedIn group page. Just visit linkedin.com and search for Vitec Corporation. Thank you so much for attending today's webinar. The next webinar in the Getting Practical with MBSE series will be Collaborative Model-Based Systems Engineering with Fran McCafferty. That will occur next week on Wednesday, June 14th at 11 Eastern. The registration link is available on our webinars page now. Remember that at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.